Here's a prediction by some of the world's biometeorologists or meteorologists of what could be the pattern of severe and extreme drought in the course of this century, given projections of climate change. And it's not a cheering picture. You can see that those are, even if we divide that by 2, this sort of modelling is suggesting that we're going to experience much more drying around the world, particularly in mid-latitudes as rainfall systems are pushed towards the poles by the warming process, and that of course is becoming an increasing worry in this country. This is the sort of relationship between photosynthetic yield and temperature that applies generally, and there have been a number of estimates of how changing climatic conditions would affect cereal grain yields around the world. The one that I've shown here is perhaps a bit generous in the estimation of the global effect, estimating that for a 2-degree centigrade rise, there would be something of the order of a 12 to 20% fall in global grain production. Other estimates are not that high, but they're all in that direction. But you can see, if you take that 2-degree centigrade figure and apply it out there on the right and the left, that in some parts of the world, as conditions get 2 degrees warmer, yields will fall quite dramatically. In other parts where temperatures are rather lower, yields will increase. There's concern about a world of gainers and losers, of course, that's reflected well in this sort of map, one of many that have been produced by researchers working in the area. But the point to note is that the browns and reds, which will go backwards, are distributed differently from the yellows which will and oranges, which won't change much, versus the blues and greens, where increased yields are expected to occur, likely to be a future source of tension in the world. Not too much green or blue in Australia, you might notice on this model. Now, the poor countries are going to be very vulnerable, of course, for a number of reasons, not just the geography and local climatic conditions, but the social and economic and cultural context as well, the dependence on agriculture economically, the limited infrastructure available to shore up agriculture against the stresses of climate change and other environmental changes, and all of those other factors which will converge then on quite a high vulnerability to the effect of climate change on the capacity to produce sufficient food to maintain good health. The last example takes us back again to a slide that Will Stephan showed us yesterday. He showed us the Grand Banks cod fishery on the left. I want to make the point that, of course, it's a more general problem, that these estimates shown on the right for the total global marine fish harvest suggest that it peaked in the 80s and has been drifting down since. Will talked about the impact of high-volume industrialised fishing on the world's great ocean fisheries, and of course that certainly accounted for the collapse of the cod fishery in the northwest Atlantic. But look at these other factors that are now converging on this story. That firstly, we have this problem of the warming of the oceans starting to displace fish populations. This was a paper published just a couple of years ago, and concluding that further temperature rises are likely to have profound effects on commercial fisheries. And of course, one of the great sleepers in the whole climate change discussion, the fact that the additional carbon dioxide in the atmosphere is leading to higher concentrations of CO2 and therefore carbonic acid in the ocean waters. It's acidifying, and this poses an increasingly worrying threat to the capacity of the marine food web to produce the chalky substances in the tiniest creatures at the bottom of the marine food web, upon which all of the larger fish and ultimately the human predators depend. So you've got this combination of overfishing, ocean warming and ocean acidification threatening this important source of food supply, which for over 1 billion people represents a third or more of their high-quality protein source, and it's under serious threat from multiple stresses. And finally, just a reminder, again, going back to the Darfur story, that whilst we can pick out the specific pathways that affect infectious diseases, food supply, fresh water and so on, all critical to the achievement of the MDGs, we must also understand that we're moving into a world that for the moment is going to become more riven by tension, conflict, displacement of populations, increased flows of refugees. It's the front page story this week on the Guardian Weekly. Europe's concern about how they're going to cope with the environmental refugee flows that they expect to mount massively just over the next decade or two. This was a quote from a report by Alan Dupont, Sydney University, and Graham Pearman, published a year or so ago. So those are the various ways in which climate change will impinge on the capacity to achieve the MDGs, and all of this reminds us, of course, that the world is not like Albert. Okay, that's it.
Tony, I wonder if you might comment on the possible effects of climate change on the great oceanic conveyor systems, the major current systems.
The great oceanic
current systems, especially the Gulf Stream, but elsewhere.
Well, there may be others in the audience that are more expert than am I on the topic, but I think all of you have seen those maps of the huge, slow-moving conveyor belt, driven largely by the warming processes in the Pacific Ocean, which drive these very large currents of warmer water around the world, such that much of the warm water that enters the Atlantic Ocean actually comes from that heated Pacific Ocean, makes its way north, and the concern with climate change that was picked up in the Al Gore movie and elsewhere is that as the Greenland ice sheets melt and we get this increasing flow of fresh cold water coming into the surface of the North Atlantic, it will dilute the natural salt concentration of the surface waters that have just previously given off the heat that they've transported around from the Pacific, given it off as they've risen to the surface of the North Atlantic, warmed Western Europe, and are about to continue the journey, head back south down the coast of the Americas, and fall again to the bottom of the ocean and become deep cool water. That cannot happen now, if and when it becomes sufficiently diluted by the meltwater coming off the Greenland ice sheet. So the concern is that climate change will disrupt that conveyor belt process, such that the surface waters in the North Atlantic, having yielded their heat to Europe, cannot continue the journey and resume their place as deep ocean waters.
Tony, what's the timescale on that one, please? Because people acknowledge it's going to happen. Some people say in 20 years and some people say in 200 years.
There's no precise answer to that sort of question, or many others, Jenny, in this area, but it's certainly not something we're expecting to happen in precipitous fashion over the next few decades. But some of the science is now indicating some weakening of that Gulf Stream circulation in the North Atlantic Ocean. But I'm not going to put a date on it. It's unlikely to happen in most of our lifetimes.
Guy Vickerman, Professor McMichael, that was a wonderful talk. Have you been asked to deliver this talk to the governors and the economists in the Reserve Bank and the HIA in Australia? If not, why not, and can it be arranged?
No, I haven't. It's a sort of talk that I'm being asked to give to the Commonwealth Department of Health. That's a small inroad. But frankly, a broader base of researchers working in this area are now starting to engage more directly with a whole range of these national government departments. And I think we're starting to get more opportunities now to make presentations within departments of agriculture and environment and so on. It's harder to get to Treasury and Prime Minister and Cabinet, but we're all working on it.
Good. Thank you, Professor Tony McMichael.